Hi, I'm Henry Golding, and this is Gamedev's Contest, a channel about all things test automation and upstream quality in games. I'm glad to have you here. Today's video is about the development of a charming game called Mission Rovee. It's releasing on April 29th on Steam, and it was developed by a team of students at Ball State University in Indiana. The game seats you in front of two old-style CRT monitors at a desk littered with 5¼ inch floppies, and there's a post-it note on the monitor with a login and a password. You type it in, and you find yourself looking through the camera attached to a rover on the surface of another world. The command line is your only interface with the rover, and by figuring out what commands you can type into the terminal, you learn how to move the rover around, manipulate its arm, and collect minerals to complete the game. But the unique setting of the game is not the only thing that sets it apart. What's most remarkable to me is the level of automated testing that the students have incorporated into their development process, which puts most professional teams to shame. By structuring their code for testability, adding tests at all levels of the test pyramid, and running those tests automatically on every commit, they have reaped the rewards of a stress-free development cycle and the ability to release at will, while other student teams are crunching to complete their game projects. I was lucky enough to sit down with team members Pandora Roberts and Jeffrey Harmon, along with their professor, Dr Paul Gestwicki, who has long prioritized technical practices that lead to high-quality code, such as test-driven development and refactoring. I hope you enjoy our conversation. I think we could all learn a lot from these students. Well, I guess, do you want to quickly introduce the game, or yourselves and the game, I guess, and the team?
That sounds
Yeah.
like a good idea. I'm Pandora Roberts. Jeffrey, introduce yourself.
Oh yes, I'm Jeffrey Harmon.
Every team member had essentially a very similar role. We had a very equitable team, and all responsibilities were able to be done by anyone. And the result of that is Mission Rovee. It's a short exploration game where you play as a rover and you control the rover with simple terminal commands.
Okay, so I guess I'll just launch it and kind of show off a bit of what we have. Sure. Yeah, so we wanted to kind of make it feel like older like computer hardware, like you just kind of found this. It's just been sitting there for a while, and you need to complete the mission. So it's all done based in the terminal. See all the commands. And your whole goal is just to move around and grab the minerals. Move a lot. Stop.
Sorry, I was trying to say something while I was muted. The sound is not coming through, but there's a really cool ambient soundtrack that our team member Robin put together. Kind of have to just imagine a really fantastic soundtrack.
Okay, I'll try that again then.
Oh yeah, I hear music now.
Okay. Perfect. I'll just
Nice.
skip that first interval.
I love the post-it notes and the whole vibe. It's great.
Yeah, we were trying to make it feel kind of like lived in, which I think we did pretty well. You can see the debug
word
menu.
in our
Just not...
in our project goals was cute.
Yes. Actually, you know what? I'll rotate. See if it doesn't like commands that aren't real. Honestly, in a way, it's kind of turned into a typing game. Like, it's just hard to type, is what we've all realized. Even this, after typing the same exact command so many times, it's just difficult.
Do you have any kind of, like, terminal stuff, like, up the command history and autocomplete?
Yes. So we do not have autocomplete, but we do have. It wasn't it wasn't something we had originally, but after doing some playtests, a lot of people who had more experience with terminals were all basically saying the same thing of like, "Hey, I'm used to doing this. Please let me do this." And so we decided that it was definitely worth adding. At first, we weren't sure what level of how similar we wanted it to be to an actual terminal, but after doing playtests, especially with more computer science students and faculty, they all really wanted that. So that was something we added, I believe, in the I believe that was post-production, so the current phase we're in. I guess, is there anything else I should show specifically at Pandora? Kind of just moving around a bit.
I think you should show the test running through.
Yep, I think that's probably important.
Yes, we'd love to see the test running.
Yes. Okay. So now you get the basic idea of the game. We're using Godot, and there's an it doesn't have tests by default, but there is an add-on for it called Gut, Godot unit tests. And I guess I can just run them all and show that off, and hopefully it shares correctly. Oh. Well, okay. See, and that's why we have unit tests, to figure out that our unit tests fail. Can you try just running this on yours? We've been doing most of our development. Okay, we've been doing most of our development on Windows, so on our in the game studio. So I haven't actually tested the tests recently on Mac, so it looks like something we changed must have done it. Which I guess is in a way, it's a good thing to show, because if this is having issues, it means most likely there's actually an issue somewhere in the game. So we probably wouldn't have found that otherwise.
Yeah, that's great. I guess I'm curious to kind of dig into what all tests you have, and maybe what levels they're at. So I see you've got the kind of full game test one. That's your sort of end-to-end test.
Yeah, so you can see it runs at a really high time scale, and it's just basically running the entire game start to finish. We've got this entire command history here, which is everything needed to complete the game. Some other ones we've got is rotating against a wall. So basically it just checks that that the rotation isn't complete when it's running into a wall, to make sure that it actually does collide with it. The arm test. Yes, that's fine. The arm test basically just tells that the that the limits of the arm rotation are correct. This is also another thing.
Oh, sorry.
I can't show the test passing. It must be a Mac issue.
Okay, I can stop sharing if you want to show that.
Well, why don't you keep the? Oh, too late. Sorry.
Oh, sorry.
To walk through the kinds of tests too might just be interesting, because there's the integration style tests and the more unit style tests.
Yeah, I think when people are kind of unsure how to get started, I think a lot of questions that folks have is how, what bits do you test? But I think a lot of people default to, I need the whole game running. It looks like you have some tests here. Now, I was curious, for example, for the rover arm, what the context of those is. Is that you have an object that is a rover that you're able to instantiate on its own?
Yes. So basically, the pivot arm is an ability that we have in the game. If we go to the ledge here, so this is the rover. You can only see it from the camera, so it's very simple because all you ever really see is this angle. Over here, there is a mineral that is actually on top of this ledge, so you need to be able to rotate your arm up and down. And what this is testing is that the limits of that it actually stops at each of those limits. So when you tell it to, you can see the first two are just that it moves in general. So pivot arm 15 making sure that it actually pivots 15.
Yeah, and the rover, if you scroll up a little bit, it looks like the rover when you create it, it's a scene.
Yes, yeah. So it's just a rover scene that is separate from the rest of the game. And here, and we're able to just instantiate it and actually run the tests with like the full model and everything.
Got it. Yeah. So this is your kind of cut down scene that you can use for testing. And is there anything special that you had to do to make this testable?
Honestly, a lot of it I don't think was anything special. It was just more. We had to put more thought in how to design it. Make it kind of by making it testable. It also made it more modular. Because we had to split, like the ARM is actually an entirely separate script and everything, which I think is probably a better thing that we actually ended up with, having the ARM separate, because it, like the rover doesn't really need to have all this control in it, where if we hadn't done the tests, this probably wouldn't have been done this way, and we might have just ended up with a really long rover script. But it made it a lot easier to test it by splitting it up, which also just makes it better code in general.
This made our input tracking a lot better because it ended up breaking each command into a separate file. And that we can now better record, okay, this command was used, this command was used. And thus we can recreate a playthrough almost exactly.
Oh, I see. Okay, all right. So because your only actions are those text commands, so you can record those and then play them back.
Yes.
Yes.
And is that what you're doing for that high level test, like the end-to-end one?
Yes. So the high level, it's not exactly recorded, but it is just running each command one after the other, and it just like it's actually doing it fully from like, it's a full integration test, I guess, from like it's inputting it into the actual GUI like the user would, rather than submitting it to any specific function, so that it's fully testing the whole way down.
Nice. Okay, awesome. So yeah, so you've got that level where you can have a list of commands that you can then process at a very high level, and then you've got your smaller scenes for your pieces that you can write tests against. Are there any lower level tests than that, where you have like objects that don't get instantiated into a scene, or is everything in Godot a scene?
Yeah. So I think the only one we have actually right now is the the inventory. So this is just a node that we add into like underneath the rover, but it itself is just it's just an object, and you can see here we can create it and then try storing minerals and making sure that each mineral that we add is actually stored correctly.
Nice.
I thought
yeah, I think.
were tests. Sorry, I thought there were tests around the parser too. Or there were at one point. Are they not there now, Jeffrey?
I also believe there were at some point, but I am not seeing them.
Yeah.
Which is
the way our parser worked fundamentally changed, and that was not a test we rewrote. We definitely would benefit from rewriting it, but the fundament, because testing with games is a good thing, but there are times when you have to change what the goal is, and that's when we have to change the test. A recent example was the arm movement was restricted to prevent clipping, but our test for it moved it downward. So we had to rewrite that test based on the changed behavior.
Yeah, I think it's always interesting, and people have a lot of questions about the balance there, about when is the right time to test and what are the right things to test and at what level. Have you? So I guess in that case, if I understood correctly, the parser, you had tests for it, but it wasn't that you changed the implementation, but and so the test could still function if it had been adjusted to point to the new implementation. It was that your actual parser behavior was different, so the test got thrown away. Is that right?
Yes.
Yeah.
Yeah.
Understood. Yeah, that makes sense. I guess when you have been writing these tests, did you have any examples where you felt that you didn't get the value that you were expecting to from them?
I would say pretty much any time that we've written the tests has been a positive. I don't think there would be any case where it was a like maybe a negative or just not any real gain from them, because almost every single one of these tests I would say have failed at some point, which means that they saved us from like having to test that manually when we changed some other feature. So I would say, if anything, it's the things we haven't tested that are things that we're kind of missing out on or like have a negative for, rather than the actual anything that's tested has actually been a very helpful thing to be tested.
Yeah, I think it's especially interesting because you've done it in the context of obviously a student project, right? So it's obviously very small scale, and a lot of times people will suggest that on a small scale indie title that you don't need any tests. But what I'm hearing you say is that actually you gained a lot of value and maybe especially important in a smaller context because you can't really afford the time to be chasing down bugs all the time.
Yeah, yeah, because we don't have a separate dedicated team to go like to fill in that role. So instead, the tests are basically that team for us of running. I mean, preferably, yeah, we'd have even more tests, and anything we change, if it changes something else we didn't intend to, it would tell us. So I think even for us, especially for a smaller team, it would be better to actually to have more testing.
Yeah. And can you? Oh, sorry. Go ahead, Pandora.
As we got used to testing in our workflow, we eventually switched to having continuous integration with GitHub web builds, and more importantly, we added commit hooks that would run all of our tests through the command line. And if one failed, that would be our first warning. The commit wouldn't work. We do the same thing with linting as well. But I found that what we gain from a test failing is usually a lot more than following our linting style guide. That's just for our convenience, but yeah.
Oh, awesome. Okay, so you have this pre-commit hook which is gonna run that runs all your tests. And how long does it
Yes.
take to run all your tests?
It's typically I think it's like 5 seconds, so it's
Oh,
not
nice.
very long.
That's great to hear because I was going to ask, my next question was going to be, how does that fit into your development process, like as you're developing? So, you know, you've kind of preempted that question.
And and that's all the test ran.
Wow, nice. That is very fast. I think a lot of people would be jealous. It looks like you made great use of that that time scaling. Is
Yes.
that's an engine feature, presumably?
Yes.
Yeah.
In Godot.
Yeah. Yeah, I played a little bit with Gut recently, but not anywhere near the extent to which you have. So that's great to see. It looked like a really good framework. And I love I love to see there's like a waiting signal or 30 seconds, because that's again like a thing that often people will insert fixed time period waits instead of waiting for something to happen with a timeout. So it's kind of the worst of both worlds. So yeah, it's great to see.
Well, on the pre-commit hook, I might be getting my projects mixed up, Jeffrey, because Jeffrey and I are working on 2 different projects too. The pre-commit hook runs headless, right? So even for the integration tests,
Yes.
if you do a commit, it'll run all those tests without even like bothering your screen, which is nice.
Yes.
If you run even faster, we have them running on the server too, which is just I was really excited when I found that last year or so you could do the whole thing in a headless instance. So it made our commit hooks a little more seamless.
Yeah, I mean that's amazing, especially that you've got it down to like just a few seconds. That's very reasonable to have in your workflow. Um, I guess maybe I'd ask: have there been times when you've been tempted to like turn off the tests or disable the tests?
I would say for tests, not really. For the linting, sometimes when you're just in a rush, sometimes it can be a bit annoying. But like for the tests, especially with it being 5 seconds, it's usually an actual problem like that will stop the game from working. So usually we've been like I think we've all been really good on like just leaving them enabled because it means something is wrong if the tests don't pass.
Yeah.
Compared to like linting, where I mean it still works. It's a styling issue, like it's which needs to be fixed. But you know, if it's the end of the class period and you just want to get to your next class or eat some food, that's a bit more likely to be disabled. But like the tests themselves have always been, I think, an important part because it's not worth committing if it's just gonna break everything.
Yeah, that's interesting as well. And maybe there are different rules in that linting that maybe would land on you differently. Because I think what I'm hearing is that you got so much value out of the tests that it was, you know, you never crossed your mind to just disable them. And maybe some of those linting rules might be maybe too strict for your context. So I would maybe even consider disabling some of them if they're not relevant to you.
Yeah.
There was a time we were working on adding a basic screen shake to our movement, just a final key bit of juice. And in the actual game itself, it worked perfectly. But with our tests being at such a high engine speed, it would just send Rovee flying out into the winds. And that was a moment where I was very tempted to say, let's just slow down the test a little. Let's just change the definition a bit. But that that would just mean eventually some player on Steam would just start flying somehow, some way.
So, if I understand correctly, then that was something that only happened when the simulation was sped up for the tests.
Yes.
Yes.
Got it. Yeah, because it's interesting that sometimes in those cases you can find like a really weird edge case that would hardly ever happen at a slower speed, but that could happen.
Yeah, I think we've caught quite a few like frame rate like dependence issues with that, where maybe we're expecting it to run at 60 FPS or whatever the monitors in there. I think they're 144, which means like if you ran it at a different frame rate, technically it would look different. But where the test caught that because of being such a high time scale, it like just multiplied the effect of that much more. So we were actually able to see it, or the test would catch it, rather than I don't know, maybe we went home for the day and tried it on a different computer and then it ran weirdly.
Right.
Or I think even worst case, we release it out to the public. They have, I don't know, one of the like 500 hertz like esports monitors, where they'd actually probably run into some of those issues. But because of the testing running at such a high engine time scale, we've actually caught quite a few of those like kind of time and frame rate related bugs.
Nice. Yeah, I imagine it'd be useful for kind of soaking as well if there are any kind of memory leak issues. So I guess you talked a lot about wins. Were there is anything that you would do differently if you had to do it again, or lessons that you would take to your next project?
I mean, for me, I'd say I think a higher focus on like actual test-driven development rather than just testing after the fact, because that would have led to a lot more tests. And like the other kind of downside is we didn't test enough. Like if we had tested even more, it would have just been even better. So I think maybe either a more heavier focus on like actual development or just even some level of kind of more enforcement of testing. I think that's honestly like not testing enough is the main problem, and nothing negative for the tests themselves.
I think for future projects and future teams, I'd suggest writing a testing methodology to help determine what features are appropriate to test and at what point in their development is the best time to start writing and making those tests. Because we did I'm making air quotes, lose time compared to adding new features, but we gained a lot of time back with having less of a need for QA testing and the ability to, okay, we're certain the game can be beaten because we can beat it in one click.
Yeah, awesome. And I guess because of the fact that you're all in the same program, there's maybe less opportunity to like A/B this on games that are made without that kind of process. Um, yeah, okay, so lots to dig into there. Hi folks, Henry here. Unfortunately, at this point we lost several minutes of the recording. There was a discussion about test-driven development and the students' experience with it. If I recall correctly, they had used it for the original parser code, and then we return just as Dr. Gestwicki is asking a question.
And explore the space and do their best. And my take on it is that when you move from pre-production to production, you're moving from wild and woolly to engineering. And that's where I would bring in things like testing. Is that what you've seen as well? Is that what you recommend? Or is there another kind of balance that you would push a professional team towards as they're going from pre-production toward production?
Yeah, it's a good question, and I think that the challenge there is that always that there's often not such a clear-cut line. The vast majority of cases, like the prototype doesn't get thrown away. So on CFDs, we were really lucky to be able to actually throw the prototype away because the prototyping was all done with deliberately like no graphics. Everything was programmer art. It was purely to find the fun, and that by definition had to be thrown away because we were building the game in Unreal. And so while they were working on that, we were kind of getting the real game kind of set up and all the processes in place and the frameworks necessary to do the engineering. But that's, I think, a very unusual situation to be in. I remember from Rob Masella's talk, from his perspective as a kind of gameplay / AI person, like he recommends in his talk not to do TDD for kind of gameplay features and not to kind of immediately jump to writing tests for things where you're still kind of prototyping, you're finding like, is this the direction we want to go in? But then once like, yeah, this is something we're committing to, then that's a good time to. I also think about it at different levels. Sometimes you might be implementing a system or a component, say, that is going to form part of something that you're working on. And I think there's a case for, well, if I'm going to implement that component and I think it's going to be generally useful for other things, not just for this thing, that I should put the effort into actually making sure that has tests so that it's a strong foundational piece, which is very different from, like, I happen to be making a component because I'm trying to just prototype this thing and see if this is any fun. I think it might have been Kent Beck who talks about when he would do TDD, and kind of has a similar take in something I read where he's like, yeah, if I really don't know if I can solve the problem or what I'm doing, then I'll kind of just code. But as soon as I know like this is the direction I want to go, at that point I'll kind of fall back to the writing tests and doing TDD.
Yeah, that makes a lot of sense. Thanks. Yeah. I'm sad that those parser tests are gone because that was such a nice little module that we had originally defined. Now that you told that story, Pandora and Jeffrey, I remember how the whole approach we're taking, the whole engineering approach, got changed and thrown away, and along with it, all those original tests that we had nice coverage for. I'd forgotten that.
Yeah, I think it also touches on a challenge that many people have starting out, which is that you find yourself with a whole bunch of unit tests, but they actually inhibit you from making changes because they're too tightly coupled to the implementation, and that like they're testing the implementation, not the behavior, if that makes sense. So I guess it occurs to me, like, even some advice I give, just even in simple things like, don't instantiate things in your test, because the classic is, you have like 20, 50 unit tests, right? And every single one is like new this thing. And then you add a constructor argument. And now you have to go update it all. So again, I always just do like make thing, right? And then you call make thing in your test. So it's just kind of like those things that as you get bitten by them. But I think that's the point where a lot of people can get to, gosh, well, I invested all this effort in writing these tests, and now I'm suffering as a result because I can't make the change that I want to make. I have to go change all of these things. It is a real thing, but it's also avoidable.
For what it's worth, I realized I had the wrong microphone on. I probably sound a little better.
Oh, that's much better.
About that. Yes, I have got my camera has a terrible microphone. Sorry, that's unrelated to anything else. Sorry about that. Oh, and I had an important connecting thought there, and I got distracted by my own microphone. But it'll come back to me. I apologize.
Okay, yeah, to do with the well, actually, I was going to ask as well. Do you have any way of measuring coverage with the tests that you have?
So
No.
Refactoring. That's the connection. Is the thing? Yes. Sorry, Jeffrey.
That's right.
I love Godot engine. I've done a lot of projects with Godot engine, but there's no good refactoring tools. So when you do something like add a parameter or rename a method, like it's just the worst. It makes me miss like Rider for Unreal Engine, right? Where it just like refactor something and bam, it just works. So sorry, that was my connecting thought.
Oh, gap in the market, maybe. So, yeah, and do you guys know the like the breakpoint coverage trick?
I don't
So
believe so.
basically, if you're so often you may find yourself in like a massive engine, and it's actually going to be a complete pain to try and implement some kind of coverage tool. Like it's on the order of like it's going to take 2 months or whatever. But you still want you're writing you're writing a suite of tests, and you just want to know how well you're doing. So what you do is you basically go and add breakpoints on every line of the code under test. And then you run the tests, and every time you hit a breakpoint, you remove it and then continue, and then at the end you're left with a breakpoint on the uncovered lines. So I've used that in real life on a very large code base that we weren't able to set up coverage tools for.
That could be,
Yeah,
again, an interesting way of automating that. I don't know if that would be the best way, but that could be kind of funny, of just like make a tool that automatically sets up all the breakpoints and removes them as it goes
That
through.
is actually how a lot of coverage tools work.
Oh, okay. Interesting.
I never
Cool, yeah.
thought to look at how they work. That's fascinating.
I'm certainly no expert on it. Hi folks, Henry here again. Unfortunately, we lost some footage at this point in the recording as well. If I remember correctly, we had a brief discussion around ways to implement code coverage collection, either through instrumenting the program that we want to measure, or non-intrusively by looking at breakpoints. And we resume as I'm asking the students a question. And you mentioned that if anything, you felt like you didn't do enough testing, which prompted me to think about the coverage. I guess, do you have thoughts on features that you wish you had tested more, or like how would you direct that?
I think especially as a closing task, that there is still testing work to be done with how our input system works, how it makes how it parses now, and how it sends those parsed results to whatever it needs to interpret that as. And I think with there being less than 2 weeks in development, I think now is the time that we think about expanding our test suite as like a more efficient way of QA testing. Because while running into rocks a bunch of times is a very fun test to be on and will help point out flaws, there are ways to automate that.
Yeah, I don't want to put words in any team members' mouths, but that's the thing that I've heard, that makes me nervous as a mentor is somebody says, "Oh, I got this really weird thing where I can flip the rover over if I put the claw exactly into this one rock." I think, well, boy, if you had a suite of tests that would just like move the rover around the edge of the map and slam into things and make sure it doesn't fall out of the world, um, that's the kind of thing
Yeah,
that I would lean toward. Again, like whether or not the team cares
yeah,
about that, but that's where I get
yeah.
worried.
That's a very common kind of test that people tend to create, actually, is tests that kind of will go around the landscape, doing raycast down and trying to find holes in the landscape, that kind of thing. And I never know quite how I feel about it, because on the one hand, I can see from the perspective of, should I, of making a choice between sending 10 people to go and run everywhere and try and find holes in the landscape, or making a tool to go do it, makes total sense. But a part of me kind of feels like, could we not validate that at the point where the asset is created? Could we not validate that when the item is placed in the world? So it's kind of, for me, an example of kind of QA think. Like this is how we QA things typically, and this is how we might automate that, rather than kind of developer think, which would be like, oh, here's a problem that keeps occurring. How can we prevent that from ever happening? And both have value, of course, and are useful in different situations. But it's an interesting one.
That's a really neat idea. I'll probably send you an email about this after the semester's over, but I've been thinking a lot about strike teams, interdisciplinary teams, and how these things play together. Because this group that you're meeting with here, both Jeffrey and Pandora, and the other 4 key members are all computer science majors. So we can talk about testing, right? It's like they
Mhm.
get it. This pre-production group I'm dealing with is half computer science, half animation, and their whole way of being and the way that they've been trained is of course quite different. And I'm not quite sure how that's going to go, right? So
Mm.
so I need to, actually, that Discord, the testing Discord, I was going to do a post there over the summer and just try to pick some people's brains on how this mentality can be used with um, strike teams, but also like what if the artists insist on being isolated, because I'm still not sure that our culture is
Mhm.
one that's going to do this versus do this. But anyway,
Yeah.
I digress. Sorry,
Yeah.
you and I can talk about this more
Yeah,
later, but
yeah, we
that's
can
been on my
definitely
mind.
talk about it, and I think like tech artists often have a great role to play there. If they often can create or can be kind of given a platform to create the tools that enable them to kind of effectively do kind of that dynamic linting. Like I think about Sea of Thieves, and one of the things we had on that was what we called asset audits, and it's now I think in Unreal Engine as data validation. But it's kind of like when you hit save, this thing will run. And one of the first, in their implementation. In ours, it was a test that ran, and basically it would kind of go over every asset and run the test. One of the first things that someone on the engine team wrote in that was just a test for, is this a reasonable complexity of geometry for its size? Right, and then from day one that was running, and so we never had like the million poly button problem, right? Which otherwise you would find maybe late in development. You'd be like, there's a weird performance issue at this one particular place. Oh, there's a few of these. It would just be an incredible problem to diagnose, whereas you can just kind of completely prevent that upstream.
That's wonderful. Thank you. Great, great. I took some notes.
Yeah. I was curious to talk about what manual testing you did and like how you felt the balance was there, and also I guess the activities that you were doing in the manual testing, whether it was kind of rote or if it was more exploratory.
A large chunk of our manual testing is, like I mentioned, a team member will be driving into rocks and seeing if the game is beatable, a- as well as a lot of our defects actually came out in our play testing, like with users out there. They would see something, or they would do something that in our normal workflow we just wouldn't think of doing because we're used to the project, and they would slip below the map or get caught behind some rocks, and it was just very brute force. And the more I think about it, the more I would have liked to, once we had our map settled upon and our collision settled upon, to have just said, okay, we're dedicating like 3 of the team members. We're making a drive around the map test.
Yeah.
Mhm.
And I especially think that would have, if we had a bigger team or maybe just more experienced team where like that would have taken like maybe less time, I think that would have been great, of like making a bunch of those, like maybe the polygon like test or like that kind of test would have been very nice to have. I think we were a lot of the times just focused on like, hitting the next deadline of like, hey, we need to have beta phase. We need to have all these phases already, where if maybe we had more experience or a bigger team, it would have been easier to say like, oh yeah, 3 of you go and work on this for a bit, rather than 3 of you being half the team.
Yeah.
But like the whole game test, for most, I think up until probably about 2 months ago, I think it was, we were doing the full game test manually, and we actually had a few bugs. There was a time for about a week, I believe, where the game was just unbeatable, and we didn't know it because we didn't have that test in. So that was actually the point at which we decided, like, okay, we've been pushing this off way too long. We just need to get a test in. So that's actually kind of what led to the full game test, which has definitely
Mm.
then saved us a few times. Where like since then the game has always been beatable, and we know that because the tests have passed.
Interesting. And so is there any I'm guessing that there's not any kind of randomization then of the locations of the minerals?
No, they are all always in the same location.
Yeah, which is very helpful for having a
Yes.
script that can tell if the game is beatable. That is something that people often go after, is the test that can tell them, can I finish the game? In particular because it's often a requirement, or don't know if it's necessarily a requirement, but it's something that you do like when you're kind of about to go into cert, or kind of about to release the game. And the problem, I think that, well, some problems I've seen with those are that manual testers still want to do them anyway because they want to do it on the final build, which will not be instrumented for automation typically. And of course, then the challenge of maintaining a stable, though if you automate it, like how do you automate it? So often people will do a replay, kind of just record and replay. Which of course doesn't work very well when things change or move around, or then you have kind of introduce some kind of system. Like I think that the Xbox folks gave a talk about their system, their bot brain system. It's like a utility AI. So you give it, it has like urges that you kind of give it priorities to, and then it will do whichever one of those it can do. So you can kind of play the game. And then I was also thinking about when you were talking earlier about monkey testing, which is obviously like the very most basic form of this, where you basically literally randomize inputs. So typically, controller inputs. In your case, it would be, well, I guess you could even do it as a, I guess you wouldn't, you kind of don't want to get into necessarily fuzzing your parser, but you can also do it with your sets of instructions. You could maybe kind of say, this is the kind of thing I want to explore, and here's a set of commands that might do this and some variables in them that you'll change, and you could randomize those. So that's like a method of kind of doing automated exploratory testing, but it's kind of diminishing returns. Like you might get some really good benefit out of it, find a few crashes and weird edge cases to begin with, but then it requires like a lot of effort, I think, to get it to the point where it's really doing a lot, and people often staff like whole teams to maintain these things, at which point it's, I don't know, it's arguable. I personally think that exploratory testing is what humans are great at, and I think aiding humans in that exploratory testing is the most useful thing. So often like giving people tools to enable them to kind of under supervision create a set of commands, or randomize some commands and then watch it happen, that kind of thing, or debug cheats, the tools to spawn things, that kind of thing. Anyway, I'm rambling now.
I think they're great stories. I've not been in the trenches, so this stories are really valuable for me, just speaking as someone who talks to a lot of students and wants stories to share. So I appreciate it.
And Pandora, you mentioned about a test. I'm sorry, I wrote down policy, but I know you used a different word. Can you say more about, I guess, what you're thinking is there, or like what that might look like and how it might operate?
Well, with my successful development teams, we've had methodologies. That was the word, that are a specific set of rules. Like, this is how we do this. This is how we share our information. This is what we do to commit. And I think just it doesn't even have to be very specific, but like you mentioned, like only not testing for gameplay, but testing for results. Basically, just a larger document, maybe like 20 or so rules that just says, this is when it's time to implement a test. This is what is appropriate for testing, and as well as what is inappropriate for testing. Like, I wouldn't believe specific random particles, like for any particle effect. That would be harder to test than like okay, moving 20 feet moves me 20 feet.
Mm-hmm. Understood. Yeah. No, I agree completely. And that is something that on Sea of Thieves, and I talk about Sea of Thieves a lot because it was just so great. But that was the way that that kind of operated was there were various policies. So there was like an overall development policy and a specific test policy, and they're basically hard rules. And the reason that it's not obnoxious is because there's a team agreement that everyone follows the rules, and if you don't agree with the rules, then you can argue for them to be changed, and then that discussion will be had, and if there's a consensus, then it will get changed. So I think that those operate really well when there's a team agreement that it's or a mechanism to trigger changes. I think where they fall down a lot and get a bad reputation is, like coding standards, I guess, is another example of this, right? They get a bad reputation because there are certain teams around the company that just ignore it completely and they get away with it, or there are some people who are like, well, I'm too busy to run the tests before I check in, so I'm just going to do it, and they get away with it, right? So I think that the important, I actually was going to write an article about this recently because I think it's so important, because it's really important to A, write the things down that you agree on, B, be flexible to change them, and C, follow them, even if you don't like them, because you have the opportunity to change them. So they all kind of feed into each other. But yeah, I've seen it very often where, if you miss one of those things, then the whole thing falls apart.
Yeah, I think it's worked really well in our team because we actually started at the beginning of last semester with like a kind of a template from Dr. Gestwicki. And then since then, it's actually just in a Git repository. So we've actually, like, if there's ever a change that people think they want, you just make a pull request and just
Nice.
update the document. And
Yeah.
there's definitely been quite a few changes. I think it's probably almost doubled in size. Like, it was not very strict at the beginning, and like just a bunch of like very core that would probably work for almost any team, like show up on time and commit with this standard and that kind of stuff. And then
Yeah.
since then, we've added new stuff, which has been more personalized for our team. And I think that's worked very well because, like you said, everybody agrees to it. Everybody knows that it's happening. It's actually up on the wall in the studio, and like everybody knows that they're being held to that and
Yeah.
has agreed to it. So it's all fair.
Yeah, that's awesome. One thing I was going to say as well, around those themes of when is enough and when to test and when not to test. I don't know your experience on this, but for me, the presence of a bug is a really great signal that there is a test missing. So I actually use that in helping people adopt testing, to kind of say, well, like, don't just go crazy and just be like, well, we have to write tests for everything just because, right? Like, let's focus our efforts on new things that are being written, and bug fixes. So I actually had like a specific line item of like, every bug fix needs at least one test, because it's demonstrably valuable because you've already had the bug.
Yeah, that isn't a hard rule on our team, but that has been kind of, I've seen like that's pretty much what we've done anyways. Like what I said with the like full game test, we ran into like a major bug of it just wasn't playable, so we added the test. Or and I think originally the ARM test, we ran into some issues and then we just fixed them and made the test to make sure that they stayed fixed. And I think a lot of ours are kind of following that pattern.
Nice. And did you run into any cases where you wanted to add a test, but you didn't kind of have the sort of framework set up to make it easy to add, and you then just kind of passed on it? It's
I
a very
believe
leading question.
whenever we've wanted a test, we've taken the time to make the framework. Like even if that's adding a simple get method to a class, we will, if we think a specific behavior needs a test, we will make it testable as opposed to passing. And I want to point something out. You said bug, and so is Jeffrey. Some members of our team are very Dr. G laughing at very particular about saying defect because bug implies it just magically appeared. That's not what happened. The team did it somehow. So we might not know how it's there, but it's still our work, and we should embrace the fact that it's a mistake we made.
Yeah, that is a more correct way to say it, for sure. Yeah, and that's a great mindset to have on the team. On that note, I guess as an anecdote, I was once in some kind of retrospective, and it was kind of like, hey, what's going wrong? What's happening? And one of the things the cards that I wrote up was, we're writing too many bugs. And it was anonymous, but there's some other people saw that and were kind of laughing about it, like, haha, yeah, it was if we write bugs. I'm like, no, we do. Like, that's where they come from. We write them. It doesn't mean that we intend to, but they do. They are the result of something that we did. So yeah, I'm definitely with you on the philosophy.
Yeah, I think especially on like bigger projects, like I mean, Sea of Thieves, much bigger scale than Mission Rovee, but I think definitely you would run into that on like bigger teams with bigger scales of there's just so much going on at any given point that like if you don't have a way to test it, some small change could change something that like an entire different team is working on, and you just wouldn't run into it. Where
Yeah.
I mean, we only have 6 people, so most of the time we can tell.
I liked what you said, Pandora, because I do think that refactoring is a key skill here. You know, like very often in the industry, you're not starting from scratch. You're in a legacy code base that is untested and untestable, and so it's quite common to, you know, when you to find a bug and you want to write a test for it, and you're like, oh gosh, well, to do that, I would need to instantiate this thing, and I can't instantiate that thing without this thing, and blah blah blah, and it's a whole mess. And it's very challenging to reach the mindset that you already have of, well, we should go make that possible. Sometimes there is I guess you always have to look at the return on investment for it, because it may not always be appropriate to do that, right? If it's going to take you 6 months, say, to pull out this piece of code that's problematic, then that's not what you want to do. But if you can reasonably, you know, make a small refactoring to make it testable, then that should be done. Other pushback that I've seen on that is it will be less performant. You know, like don't make this change to make it testable because it would be less performant. Often comes up in the context of virtual methods. People will say, "Oh, don't make that virtual," and I don't think it's even necessarily true. Like I am not the world's greatest authority on C++ these days, especially. It's changed a lot, but someone who I believe who I respect, is firmly of the opinion that, you know, there's no problem with using virtual functions, and I'm sure that may get a lot of people may not agree with that. It's always context dependent, but I do think that there's in general a mindset that testability isn't a thing, you know, because it hasn't been in the past, you know. So the code base typically has been created without that as a constraint. And then trying to introduce it as a constraint, so you run up against not only the code base, but also the culture of the people around it. Because they're like, well, we've had to think about this before. Should we really? It's like, well, yes. And the reason is, as you have found out, that it enables you to work faster and not have to spend all your time doing manual testing, and you can actually develop things. Awesome. I think you covered everything that that I have on my list of questions. Is there anything else that anyone wanted to add?
I'd like to add that I've heard from people in software that being tested isn't something your client, your customers care about. And I thought about that for a while. And then I watched a car commercial. And that car commercial is saying #1 tested, #1 certified. So I believe not just in games, but in software in general, that's a very marketable thing if you know how to say it right. And I think that is something we should, like, even with this little article that is marketing Mission Rovee as a tested, thorough game. And that is something both industries should move forward into, like, proudly telling it to people. Even if, because most people don't know what it means to test a car, but you hear it's been tested and you're like, okay, must be a good car.
Yeah, I guess maybe the pushback you might get on that would be, oh well, but a car is safety critical, right? Like it makes sense. So that's something that people are concerned about, because they could be hurt if it's not the case. But in the context of a game, there may be less desire for that. But what I would say though is, I don't disagree with you, by the way. But I think that, well, I on my Substack recently, I did like Henry here, yet another lost piece of recording, I'm afraid. At this point, I'm talking about the Substack article that I wrote, which was a version of Martin Fowler's article, only changed such that the context referred to the games industry rather than the wider tech industry. But the main point he makes in that is that he makes the distinction between external quality and internal quality. So external quality being what the customer perceives, and internal quality being, you know, things that we perceive as we operate on the code base. And the value of the internal quality is the ability to adapt and change. And so he ends by saying that any kind of moralistic arguments around quality are basically doomed, right? In the current business structure that exists, you can't say, well, we should test this because it's the right thing to do. It's not an effective argument. So it has to be, a financial argument, and there is a good financial argument, which is that the products with high internal quality, they are developed faster and more and cheaper, basically. Yeah, I guess in your case, it's kind of a testament to that, that you've been able to produce, a polished product that you've been able to, release on Steam. That's well done, by the way.
Thank you very
Thank
much.
My one final question, I guess, was with regards specifically to the test framework, GUT, and how to use it. Is how would you rate like how hard it was to onboard to that? So maybe kind of coming from not having used it to I'm learning about it, and then to okay, I feel good. I know all the ins and outs of it. I can write tests using this. It's just part of how I do it.
I would say coming from other testing frameworks, it wasn't that difficult. I think the hardest part was figuring out how to get it to actually like interact with Godot specific stuff, like the signals and I guess instantiating like for the integration tests. But I mean, otherwise it's very similar to other testing frameworks I've used. I think it was, but I'm also on like, I think I'm on 2 separate projects using GUT. So I think I've had like almost double the like 2 entirely different things of like one being a 2D like choose your own adventure game basically, the other one being this. So I'm also getting both sides coming in at the same time. And I think it's been very interesting also like even if it's 2D, 3D, different way of interacting, it's the same thing. Like it's just code. It's pretty much all the same. Once I was able to figure out how to actually get it to interact with Godot, like it wasn't really any different between the two. Just testing different things.
Jeffrey, do you remember if it was this project or the other one where we had to spend some effort on the orphan management? We were trying to keep the memory footprint clean, but I can't remember which project that was now.
I think it was a little bit of both, but I believe it was a bigger problem on Mission Rovee on this one.
Okay.
I remember killing plenty of orphans.
Mm-hmm.
Yeah, well, that's I guess that's kind of an example of the kind of maintenance that arises as a result of doing testing. So again, that can sometimes be brought up as an argument against, kind of, well, well, you're having to do this. If you weren't doing any testing, you wouldn't have to do that. And again, it kind of, I think what we need to do is refocus people onto, well, why are we doing the testing? It's because it saves us time and money, right? And as long as the activities that we are doing to put the frameworks in place and keep them running are not, excessive, then, they don't outweigh the time and money we're saving, then it's worthwhile.
Yeah. I think actually in my other project with Dr. Gestwicki, I believe the orphan issue that we had was actually we were testing kind of a higher level like integration test, like for the whole GUI, I believe. And we actually found that there were like pieces that weren't being freed or parts of like nodes that weren't being freed. So I think even though that wasn't what we were testing for, we actually found even other issues that we just wouldn't have found otherwise because it was testing a higher level component and there was an issue like that if you were testing the individual smaller components, we wouldn't have found it because we would be freeing them ourselves. But just in the specific way we had it implemented, there were just leftover parts that the test actually found for us because it was just, even though that's not what we were testing for.
Mm.
I remember that now because it was always a multiple of 4 of how many times the test ran, and that was how we ended up triangulating towards it being a real problem, like because that was too weird. Yeah. Anyway, yeah, that I remember that now, Jeffrey. Thank you.
That reminds me of kind of like the crash on shutdown, or which is often a thing that plagues projects. At least in my experience. There'll be something that happens, and it only happens while the game is shutting down, and it crashes during shutdown. And then during development, you're like, well, I just kill it, or move on from that. But if you have tests that are running, then they're going to catch it every single time because they have to shut the thing down at the end. So again, it's one of those things which is a tension between, well, you could ignore this and we could fix it later, or we could fix it now because we have to, because it's blocking all the tests. Yeah, I think a lot of it just comes down to the mindset, and I think it's great that you're operating from the mindset of seeing the value that the tests are giving you. I guess. Do you have any kind of ballpark back of the envelope idea of like how much time you saved, or even maybe from that time that you automated that end-to-end test that you were previously doing manually?
I feel
Yeah.
like we would have needed to do another gather we did 3 play tests with actual players, and I feel like we would have needed a fourth to get all the data we gathered from what we automated. And we simply did not have time to do a fourth. We're lucky we got in our third, and we just each one of those took about, they were always estimated around 8 hours of work with scheduling, marketing them, and then processing all that data. And we cut that down into like a 2 hour process of writing a test and then running it every day.
Yeah, and I think from like the full game test side of things, we probably wouldn't have tested at every commit. But by doing this, it is tested every commit, which, I mean, the 5 seconds that it takes to run probably saves like 10, 15 minutes, I would say, to do that manually. Because the game is, like, it's supposed to be more kind of like slow-paced, kind of like relaxing. So where if you were not the 5 second, obviously, but I think probably a good like 10, 15 minutes, almost every commit would have been saved if we were wanting to test every commit. But actually, though, we wouldn't have otherwise. So I'm not sure exactly how to phrase that, because it's time that wouldn't have been spent, but it also was still saved.
Right. It's always very hard to quantify a lot of this stuff, which is actually something that makes it hard to advocate for, because a lot of the benefits are intangible, and no one ever gets credit for fixing problems that never happened. Which is the title of an article that I like, by the way. Repenning and Sturman, I think, of a business review. It's on the Trello board. It's one of my favorite ones because it really makes that link between. Well, I won't talk about it now because we're running out of time. But it's good. Well, I guess what would have happened if you didn't have the tests? There was someone saying you will not write any tests. What do you foresee would have been the outcome?
Less juice in our game. I believe with the time we've saved from test, we were able to add a bunch of little things like some atmospheric fog, an extra asset compared to our placeholders, and without the ability to cut time down on finding out what's broken, we would have not been able to. Camera shake is the best example because that was really dependent on our testing, because it pointed out the flaws, it pointed out when it would break, and it was a very difficult bit of juice to add. But if you compare the game before and after, it's very necessary.
Yeah. So you've created a better and more polished product.
Yes.
Yeah.
That's an interesting take, Pandora. I just want to riff on that for a minute because I hadn't thought about it this way originally. Because these are all students, to get a good grade, they have to release their game. So they're going to release their game no matter what, but they're releasing something good because they have the time to make it good. So they would have released something just to pass, and that would have been disappointing if it wasn't good. So Pandora, thank you for helping me articulate that. That's great.
Yeah, and I think another thing in our case actually being all developers and one musician, but the time like spent fixing bugs in a normal team kind of is separate to the time of like creating assets or maybe adding like the atmospheric fog. But for us, since we are the entire team, developer, artists, is all the same people. Any time spent like fixing bugs is actually just taking away from like making another asset. So like how Pandora mentioned of like adding the assets, I think that could be maybe like a kind of unique case in our situation compared to maybe a bigger team or even just a multidisciplinary team.
Yeah. So as you came up to your kind of release on Steam, was there a period where you had to like crunch down a whole bunch of bugs, or were you just like what we have is what we have and it's good enough to go, we can keep adding stuff, but there's not anything like wrong with it that we have to like scramble to fix before we put it on Steam?
I think we've always been in a steady place where defects will occasionally arise, but there's never like a myriad of them. It's just okay, we have a continuously build of our latest commit, and that is if we ever need to emergency push to Steam, we have it, it works, and we can send it out. Of course, there have been little things we've added since then, like we've replaced some models, we've added and a bunch of other little touch-ups, but we've always been ready to push to Steam. One thing that did scare us for a little bit was we had commissioned out art, and it took a bit longer than what we would have liked. But even then, we had a backup plan of assets we made, not very good assets, but stuff to put on the Steam store just to fill in the image slots, so we could release on time.
Yeah,
Do
that's
any of you
amazing.
happen to
And
have-
I was going to
Sorry,
say, and that's an expected benefit of developing in this way, right? Is that you can release on demand.
I just wonder, Jeffrey or Pandora, if either of you has the projection chart just on hand, just as a demonstration of how post-production has gone.
Yeah, I can pull that up if you don't have it already,
This
Pandora.
was a bit of an experiment for me as a mentor to try to figure out how to manage. With a small team, we could have done something different, but trying to come up with a more scalable way to manage the 5 teams we'll have next year. I don't have it right on hand, though, so hopefully one of them has it right here.
Post-production.
It's kind of a visual answer to the question of like, are we stressed out? Because we're not stressed out, which is a nice place to be.
Yeah.
I'll pull up an older example to show times where we didn't have all these frameworks in, and it was quite a panic.
Yeah, so here is our post-production chart. So this is like the most recent section we're going through. And you can actually kind of see in here sometimes it's been relatively consistent. There's been a few cuts, like you can see right here, we actually cut a bunch of content. Actually, can you see my mouse?
Yes.
Okay, perfect. Yeah, so you can see right here, there was a big cut. But most of that was actually just like content, I guess, or kind of like extra stuff rather than, it wasn't because we were stressed because we had to fix bugs or anything. It was just, we haven't done this before. We didn't estimate correctly, or we overestimated how much we could complete in time.
Yeah.
So I would say.
Oh, sorry.
Oh, you can go ahead.
Oh, I was just going to ask, in those bars of those work items, like what percentage of those are bugs?
I would say maybe like 2%. Yeah. Like there at any given time, I think we probably have max like 2 bugs, because those are also always the first thing to go. If ever there's a bug, it is added to our chart. I can actually pull up the hacking plan as well. If there ever is a bug, it is added to the very top of our list and is the first thing to move out into in progress. So you can see there's some bugs in here, or defects, sorry, defects. There's some defects in here, but they're minimal and they didn't last very long. It would be usually, if we notice them sometime at the beginning of the meeting, they would be finished by the next meeting at the latest.
Yeah, awesome. Yeah, and so like looking at your burn down there, that was kind of what I imagined, that it wasn't a bunch of bugs, which is highly atypical for people closing down a project. And it looks like you've been doing productive work like right up until the end, basically.
Yeah, and it's actually led to like kind of a perfect place where, I mean, now we just entered like the 2 weeks period where it's now public on Steam, but it can't be released until the end. And technically, I mean, we don't have any more features that are in here. We might add a few more, honestly, just because I think a lot of this is kind of like maybe more individual people, but I know, and I've heard a lot of stories of like, yeah, the crunch for the last few weeks. We don't have that. We're basically done. Like everything else,
Yeah.
everything else now is just polish or things where like,
Yeah.
actually, that'd be kind of cool. It'd take an hour. Why not?
Yeah. No, I mean, it sounds great. Like, I wish my student projects had been like that when I was at university. I didn't know about this stuff back then. But yeah, no, I think it's a really great illustration of, you know, the approach that you've taken has given you these great benefits, versus the kind of classic, oh, just feature all the time and forget the quality, because you're just saving up a massive store of bugs that you're then going to have to panic to burn down in the end. And it's, you know, there a lot of times with defects, it's they're kind of inestimable, right? You can't really say without doing the exploration to find out what they are, like what the fix would be or how long it's going to take. So they're a really risky form of work in progress to hold right until the end. All right. Well, I want to say congratulations. It's definitely. I imagine. Well, let me finish. I'll finish my congratulations a bit first. Well done. You've done really great. This is amazing.
Thank you.
Great to see that you've been applying those practices, that they've worked for you, and that you've held that kind of strong mindset and reaped the rewards, which is awesome.
Yes, it's
Also,
been
go
very
ahead.
good compared to like other projects with maybe less testing of like, yeah, like the other projects, they're kind of pushing towards the deadline. This one is fine. This one's been great.
Awesome. Well, any last words?
If there's a Mission Rovee expansion, we will have more of our features tested before we start expanding our map or adding new things to do.
All right.
I really appreciate the time that you've shared with my students. Thank you so much for listening and asking questions and sharing your own experiences with them and with me. Thank you so much.
Yeah, it was absolutely my pleasure. It's great. You know, I love supporting education. You know, and so especially, you know, a course where your students are learning this kind of practices and seeing great results from it. It's awesome. And yeah, I'd love to do everything I can to help publicize that. All right. Thanks very much, everyone. Great to see you. If you made it this far, thanks for watching, and if you enjoyed this video, please consider helping me grow this channel by liking and subscribing, and remember, despite what you may have heard, game devs can test. See you next time.